Do you think IDMs and pure foundries would come up with different approaches for silicon carbide fabrication?
That's a great question. So as I mentioned before, it only takes a very modest investment in order to process silicon carbide in a silicon fab. So you want to basically exploit all the mature technologies that are available in silicon and can be used in silicon carbide. You basically do not want to reinvent the wheel. However, silicon carbide, because of its specific properties, you need to have certain fabrication aspects that are unique to silicon carbide, and therefore they need to be developed. So the investments that you need in tools, so tools that do not exist in a silicon fab and are needed to do silicon carbide, again, they're in the 12 to maybe $15 million investment, which is a relatively small investment. And then you can start having silicon carbide fabrication in a silicon line. Now, the one thing to keep in mind is that when you look at the model of silicon, the fab model of silicon has been duplicated in silicon carbide, but there are two distinct differences. In silicon, there's an abundance of good, high quality substrates, wafers. In silicon carbide, there's a lot of work that companies are doing to secure that supply of wafers. That's number one. The second thing is silicon companies compete on design alone. You design to certain design rules, and the fabrication processing that takes place in the fab, it's kind of a black box to the designer. In silicon carbide, you're competing not only on the design, but you're also competing on the processing. So processes that are not available from silicon have been developed by every company, some of them in their own unique way, or the way that they're tied together to the overall processing is kind of unique. So if you're an IDM, and let's say you're silicon carbide only, or you're an IDM that does silicon and silicon carbide on the same line, you've developed your processing and you're running on the line, you have your different products, and that's very much similar to silicon. If you look at the foundry model, however, where fabless companies will come to process, every fabless company that comes to you has certain silicon carbide processes that are unique to them, and they have IP. So unlike silicon, where you have a place like TSMC, the largest foundry, or other big foundries, where they give you a set of design rules and you just design, to those rules, and you kind of compete on the design. In the case of a silicon carbide foundry, you'll have people coming in with their design. They'll need to design to your rules, but they will also have their unique processes, certain unique processes in the silicon carbide fabrication. So it's really how to leverage those processes in a way that you still maintain the economies of scale. So what I mean by that, if you have 20 different companies coming in with 20 different ways of doing 5 or 6 different steps, it becomes chaotic very, very fast. And in the end, you're not able to maintain the economies of scale. In order to maintain the economies of scale, really, you need to be running the same process throughout your fab. So that is a distinction in the case of silicon carbide, foundry, pure foundry fabrication for fabless companies. And there are ways to do this successfully. There are certain ways where you can be a pure foundry and be fabricating devices for a number of fabless companies, and you can do it in such a way that you maintain their IP, you help them have the differentiation in product that this IP allows for, but at the same time, you're able to maintain the economies of scale that will make you competitive when it comes to competing with the IDMs that do not have that problem, because the specific process they have for silicon carbide, they're theirs, and they only have one way of doing them. In a fabless company, you can have an implantation with 20 different customers doing it 20 different ways, and that can lead to a lot of extra labor. With respect to the design, you have some design rules for your foundry, and people will design to those, right? But there are certain steps that people have IP on, and they might not be willing to follow what you have available. So one of the key things to do is, out of all the silicon carbide specific processes, the ones that are not available in silicon, and therefore people have developed their own ways of doing that and their own IP, for some of them, at this point, they're at a level of maturity where you can actually offer a single solution that is high yield and high performance. So therefore, everybody coming in with a different way of doing that process, you can show them that this is how we do it here in this foundry. These are the yields, so you should be fine. You don't need to do it in that specific way that you might have. But there are other processes that are truly differentiating and specific to certain companies, specific in the way they make their products, and you need to accommodate those. So really, you need to find a balance between those two in a way that it keeps the IP that differentiates the customer product so they can have the performance advantages or the yield advantages or the reliability advantages, whatever their process allows for. But at the same time, do it in a way that you don't increase labor to the point where the economy of scale is gone and you're really running 30 or 40 different processes in a single foundry, which is, of course, cost and labor prohibitive.